In this paper, we present tBox, a new 3D transformation widget that has been entirely conceived for the purpose of touch-based interaction. 3D transformation widgets rely on the standard mouse and keyboard paradigm, where users benefit from accurate pointing, distant interaction, an unobstructed view of the screen, and direct access to numerous buttons and keyboard shortcuts. Unfortunately, touch screens have none of these qualities. tBox is a box-shaped widget where rotations are controlled by way of straight gestures. The user spins the tBox as if he were spinning a physical cube. The gestures were determined with a pilot study. Subjects were asked to draw a gesture that would make a cube spin. This study revealed that very comparable gestures were used from one subject to another and from one view to another. When the user touches a handle, a sliding widget appears. The translation mode starts when this widget is moved to the end of the corresponding edge. This mechanism, inspired from what is done in 2D, ensures safe activation of the translation mode. Here, successive refinements with 2 fingers allow the user to quickly reach a 3D location. Both fingers can be used simultaneously to translate the object in a 2D plane as well. A double tap on an edge allows to release one finger. Multi-finger input is used for scaling operations. Pull-apart gestures of both sides of the widget increase the size of the object. To scale along one axis, the user selects 2 opposite edges of a face and moves them away from each other. For each primary axis, 2 to 3 handles located around the focus area can be accessed. Hence, the user avoids occlusion issues. The handles project at different screen locations, making their selection non-ambiguous. Here, back handles that project too close to front handles are automatically disabled. This prevents erroneous selection. Other handles remain available for the selection of an axis. Translation, rotation and scaling can be chained in a fast and safe way. Double tap selects an object. By default, the tBox widget is centered on the selected object. Here, the user deselects the object and moves it in 3D space. She keeps a finger on the widget to attach the latter without centering it. Hence, she can easily change the pivot point. Pull-apart gestures outside of the tBox widget control zoom. Double finger movements are used to pan the view. Orbiting is controlled by defining the pivot point with one finger, while moving the camera with another finger. The pivot point can be the center of the world, as illustrated here. In this example, the user translates an object while adapting the view with her second finger. We ask subjects to play with our system. This preliminary study showed that novice users were able to manipulate 3D objects in a fast and easy way. tBox contributes to bridge the gap between computer graphics and touch screens. It brings 3D transformation widgets from their current desktop environment to new, broader usage and context.